Continuing with this series of videos on three-dimensional geometric solids, we are going to talk about prisms, and in this particular case, a triangular prism. What makes a prism different from a pyramid? The pyramids that we have mostly been working with have been square-right pyramids. For example, in this problem that we've already done in another video, notice that we have a square as my base. So I have one base, which in this particular case is a square, which has four sides. And out of that, you're going to have four different triangles, which are going to be the faces of this square pyramid. So we have one in the front, we have one in the side, we have one back here, and then we have one on this side. So there's going to be four triangles that are going to come out of this square base. One base, four triangular faces, and they all meet together at this vertex up here. So this is a pyramid. The problems we're looking at right now in this video is what's called a triangular prism. In a prism, we have two congruent bases. And these are triangular prisms, but we can work with an octagonal prism or a hexagonal prism, where both bases would be hexagons or octagons. But in this case, we're going to have two congruent bases. That's what makes this a prism. And they are triangles. So notice right here in the front, it almost looks like a piece of cheese. If you've ever seen one of those cheese wedges, this is what it looks like. So I have a triangle in the front. I have a triangle in the back. Those are my two congruent bases, and they're going to measure exactly the same. EB is the same height as FC. If DC is 15, so is AB. DF is going to be the same as AE. So right there are the two triangles. Now these two triangles are joined together by rectangles. So here's one rectangle that's going to join those two triangles together. At the bottom, I also have another rectangle that is going to join these two triangles together. And at the top right here, we also have another rectangle that is going to join these triangles together. So in reality, if we talk about a pyramid, I'm going to draw what's called a net. I'm going to attempt to draw, okay, because I'm not an artist by any means. But in a pyramid, the way the net would work is that I have, let's say it has a square base, and then my four faces are triangles. And those triangles, like I explained to you at the very beginning of this video, are going to all come together to connect at one vertex. A triangular prism is different. In a triangular prism, you're basically going to have two triangles. And because a triangle has three sides, then the way the net would work is that you would have the three lateral faces, which are rectangles, and then you're going to have the two triangles at either end. Okay, so here I have two congruent bases, in which case we have two triangles. Here I only have one base. The lateral faces in a prism, in any prism, are in the shapes of rectangles, whereas the lateral faces in a pyramid, in any pyramid, are going to be in the shape of triangles. So hopefully that gives you an idea of the distinction between a prism and a pyramid, because it's really important to make sure that you are working with this correctly. All right, now that we've established the difference between a pyramid and a prism, let's go ahead and see if we can answer these questions. For this triangular prism, calculate the height EB. EB is back here. Remember that in a lot of these problems, we are trying to combine what we know from trigonometry so that we can apply it into these geometric solids. Right now, I see that I have a right triangle right here. They have given me the fact that this angle EAB, measures 21 degrees. And like we mentioned earlier, if DC is 15 centimeters, then AB also has to be 15 centimeters. One of the biggest things that I am a big proponent of is to take the time to redraw just the part of the figure that you're interested in solving. It is going to help you avoid making mistakes if you actually take the time to redraw this, okay? If you're really good at math and you're very good with your spatial ability, then you can probably bypass this and you can get the question correct, which is wonderful. But for those of you who are watching this video because you are really not as strong in math, I would highly encourage that you take the time to redraw this triangle. So now at looking at the triangle by itself, it becomes a pretty simple trig ratio problem. I know the angle is 21. Because it is a right triangle, then I can work with sine, cosine, tangent, SOH-CAH-TOA, to try to determine which one of these trig ratios can combine. In this case, what I know, which is that 15 is my adjacent side, and what I'm looking for is this right here, which is my opposite side. So let's think about what is going to connect opposite with adjacent, and the answer is tangent. So we're going to set up the problem as the tangent of 21 degrees is equal to opposite, which is EB, over adjacent, which is 15. This is easy. We're going to take 15 and we're going to multiply it to both sides so that we can figure out the length of EB. Take your calculator, make sure that you are in degree mode, and let's do 15 times the tangent of 21 degrees. And we're going to get approximately 5.76. In this case, centimeters is approximately the length of EB. Let's take a look at the second part of this question, part B. In part B, it says to figure out the length of line DB. Okay, I'm going to go ahead and erase what I have done right now for part A so that we can kind of look at this clearly again. In this particular case for part B, we're looking for the length of the line DB. Notice that DB is a diagonal that connects point B with point D. That in this case is connected to this bottom rectangle. Because every single corner is a 90-degree angle, then I can go ahead and work with one of these triangles so that I can figure out BD. I know that right here, I have a 90-degree angle because it is in that corner cut by this diagonal. If you can't decide where the right angle is going to be, one of the ways that you can try to figure that out is to literally take the time to redraw the rectangle so that you see it drawn flat in a way that makes more sense to you. In this case, the bottom rectangle is rectangle A, B, C, D, and what we're trying to find is the length of diagonal BD. Because this is a rectangle, I think now it is a lot clearer for you to understand that angle C is a right angle. Let's go ahead and fill in information that we know. We know that DC is 15 centimeters, and because AD is 23 and opposite sides are congruent in a rectangle, here it is also 23. So this means that I'm working with this right triangle DBC, where DC is 15 centimeters, BC is 23 centimeters, and my job is to solve for DB. This is a right triangle, and we've been doing this in all of these videos that deal with using trigonometry to solve problems that are three-dimensional figures. So we're going to go ahead and set up the problem by doing the Pythagorean Theorem. 15 squared plus 23 squared is equal to DB squared. Remember, the hypotenuse is always the one across from the 90-degree angle. And in the Pythagorean Theorem, a squared plus b squared is equal to c squared. This c is always the hypotenuse. 15 squared is 225 plus 23 squared is 529, and that is going to equal dB squared. Add them together, 225 plus 529 is 754 is equal to dB squared. Remember that you have to take the square root of both sides. So if I take the square root of 754, I'm going to get that dB is approximately 27.5 centimeters. So I've gone ahead and I figured out the answer for dB, which is 27.5 centimeters if I round to 3 significant figures. Okay, in order for us to kind of get our thoughts in order, we're going to erase all of this again so we have a clear picture when we go to answer part C. In part C, we're now asked to find the length of line DE. Let's find line DE. And there's actually multiple ways for us to do this problem, but they're going to entail a little bit of work. If you focus on the answers that we've already been asked to find, we know that EB is 5.76 because we were asked to find that in part A. We know that DB is equal to 27.5 because we just finished finding that in part B. And now they're asking us to find DE. Well, what I have is a right triangle, which I'm going to redraw right here. This is E, B, D, and I know that DB is 27.5, EB is 5.76. So notice, here again we have a clear classic case of the Pythagorean Theorem, where 5.76 squared plus 27.5 squared is going to equal DE squared. Take the calculator, do 5.76 squared plus 27.5 squared. That's going to give us 789.4276 is equal to DE squared. Take the square root of both sides. So about 28.1 is going to be the measurement of DE. So 28.1 centimeters is going to be the measurement of DE. Finally, in part D, we're asked to find the angle that the line DE makes with the base of the prism. And they were kind of nice enough because you can tell that right here, this is the angle that they are referring to, which is the angle that DE makes with the base of the prism. So we already have this triangle drawn. That's basically the information that we want. According to the triangle, opposite of this angle, which I'm going to go ahead and call theta, is 5.76. The other side is the adjacent side. So that means that I have to figure out, by using once again trig ratios, sine, cosine, tangent, SOH-CAH-TOA, I have to determine what's going to connect my opposite side to my adjacent side. And the answer is going to be tangent. So that means the tangent of theta is equal to opposite over adjacent. The only time that we have to press second in the calculator, or if depends on which calculator you're working with. In your calculator, it might be pressing shift. Then you're going to find what's called the arc tangent of 5.76 divided by 27.5. If you're still having a hard time with SOH-CAH-TOA, I highly recommend that you take the time to watch the videos on them, because that way you're going to get the practice. The more you practice your math, the better you're going to get at it. Here, this answer is about 11.8 degrees. So there you have it. Now we have been able to answer all of these questions on this triangular prism. Hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.